Hey, this is going to be a course on software architecture, specifically in the sense of web development and building web servers and APIs. A lot of these concepts will translate really well to any other kind of software programming. So if you're building, games or mobile apps or whatever it is, it's important to have architecture discussions beforehand and figure out how it's all going to work. A lot of those things interact with web servers anyways. So you need to start thinking about what's our system going to look like, what's the product look like, how's it going to work, excuse me, what data do we need to keep track of, and how does the whole system tie together. So that's all of that's all different aspects of software architecture, and there is a specific order to how things should be done. And I'm going to kind of go through a list of topics here in a minute, and then I'm going to have separate videos for each topic and kind of go into more detail, and then I'll also give examples. I'm going to think up an example application that we can kind of go step by step and build it out as we go. So you're going to have a specific order that you're going to do these things in, but at the end of the day, it's always going to be evolving and it's always iterative. And so as you work down the list from top to bottom of the order that you're going to think about these things in, you might find things down the list that affect how something needs to be done in an earlier step. So let me shrink my video here and kind of give you an example of what I'm talking about. So architecture, I guess real quick, I'll just cover why is architecture important? Well, in a lot of other industries, it's really easy to see why you need architecture. So if someone's going to build a house, it's a really easy example to translate to software architecture. You need to first come up with a design, right? What's the house going to look like? What are we trying to build? Once you know that, then you can have an architect draw up a blueprint, right? Here's where the rooms are going to be. You can have a structural engineer do the math to figure out where your load-bearing walls need to be so that it's safe, so that it's livable. And that all translates really well to architecture and software. If you don't know what you're building, then people are going to be building all kinds of stuff that's not needed or not relevant, and you have to rip it out or redo it later on. Once you know what you're building and you have a general idea of what the product should be, you don't have to have everything fleshed out product-wise, but you should have a general idea of what you're trying to build. Then you can start designing your system. So once the product design's done, you can start doing system design. And system architecture is all about what pieces of the system are there going to be. Are we going to have multiple servers that keep track of different like microservices, right? That keep track of different parts of the data. How do they talk to each other? How do they interact? Or is it all just one monolithic, one code base, one server? Here's the code. And there's more that I'll go into in detail on those thought patterns and how to figure that out on the video on system design. Once you have your product kind of figured out and you know what your system's going to look like, then you can start building your infrastructure. And I've kind of grouped, I'm going to do a video on infrastructure, IT, and security, just because in a small company especially, those kind of just get grouped into one team a lot of times. In a bigger company, you'll start to see them break out into multiple teams. But once your system design is done, then you kind of know, okay, we need a database here and a database here and 5 servers and load balancers and firewalls, and you start setting all that stuff up. Once your infrastructure, and this is an example of what I was talking about earlier, once you start doing your infrastructure, you might come across some weird obstacles and you say, oh, actually, thinking through the infrastructure in a little bit more detail, we actually need to change the system design. And, we need to, change a few things, flip these things around, whatever it is. So as you go down the list, certain things might impact earlier things. They're all interrelated. But it's important to kind of go in order and talk about these things one by one. And the same thing with system design. Like if you start talking about the technical feasibility of some of the things the product team came up with, some things just might not be possible, or maybe you have to design things in a certain way in order to make it work. So there's always some back and forth, and you have to iterate and go step by step, and kind of it'll evolve as you go. But once you have your infrastructure kind of in place, then you can start building code. But before you start writing actual code, it's important to think about your data design. Really, at the end of the day, all of our code, the purpose of it is to interact with data. Data is what people use your software for. And if you're doing like game development, maybe that's not true like 100%, but even with game development, you have to keep track of data. Like you have characters with I don't know, like health, right? And they interact with each other, right? You have to have data. You have to have data management, and you have to save that data. You have to keep track of data in a database somewhere. And all of your code that accesses the data, specifically for web servers, it's built on top of your data access patterns. So you need to think about what data do we need to keep track of, and how should we organize that data in different tables, and then how are we going to access that data? Because the rest of your code is kind of built on top of that. And so once you know what your data is going to look like, then you can start doing code design. And so that's not just how are we going to access the data, but it's code design in general. How are we going to organize the code? What kind of coding patterns should we use? And I'll do a video and go into more depth on some of that. There's people that spend their entire career learning about this stuff, so I'm not going to pretend to be an expert on all things code design, but I've seen lots of different ways of doing code design, and I've seen ways that work, ways that make a lot of sense to me. They're very logical, and they scale well. And I'm going to say for all of these things, there are certain aspects of this that I don't have a ton of personal experience with, and I won't do an example. So with each of these steps, for the ones that I know a lot about, I'm going to kind of do an example and I'll code it out and you can see what I'm talking about. There are some steps like infrastructure. I've set up servers for my own personal projects, but I haven't ever done it at an enterprise level. I don't feel qualified to show examples about that specific category. But a lot of these other ones I do. And I've been on teams, we've built software that serves millions of users. I've helped applications go from something, it worked for tens of thousands of users, but now they're scaling to hundreds of thousands or millions and things are breaking down and we need to reorganize and re-architect it. I've been on those teams. I've helped re-architect and rebuild software to work for millions of users. So I've seen ways that work. Now, once you scale past millions and you get into hundreds of millions or billions, you might have to re-architect again. You might have to think about things differently. Let me just shut my door here. So if you work at a big company like Google or something that's, their throughput is so high, then you might have to think about things in a different way. But for the majority of applications that we build, as long as you can write it in a way that's scalable for millions of users, that's good enough to get you going. So, and I've done that on multiple teams at different companies, so I've seen ways that work, and I'm going to talk about all of those. And then this last thing here, processes, it's not really architecture related per se, but it is important. It's important to have processes. It's important to have team coordination to make sure that everyone knows who's working on what, so work isn't being duplicated. A lot of times you can have 5 or 6 different tasks that need to be done, but they all rely on this other thing being done first. So it's important to kind of think about those things and establish processes so that things can get done in a proper order and that the work can get divvied out appropriately. And then beyond just processes for organizing teamwork, it's also important to have continued architecture discussions. Maybe once a week or every other week or maybe once a month, depending on your team size and who else is participating. It's important to continue to have these discussions because if you have a few meetings up front and decide what you want things to look like and then you start building it, as you build, a lot of times once you get into the weeds, you start to see issues. This thing that we thought was going to work isn't really going to work for this specific reason, and we need to tweak it a little bit. And that needs to be something that everybody knows so that because you're changing the location of the target, you're changing what you're building. So you need to continue to have these conversations and these meetings on a regular cadence so that everybody can stay synced up and know what you're building and what you're working towards. So that's it for the overview. I will do a separate video for each of these different topics, and we will do some examples as well.